Okay, question 5 on the foundation paper 2. Verity is arranging these 6 identical tiles into different shapes. Okay, so the fact that identical is important because obviously it means that that 2.6 happens everywhere. Okay, each tile is a square with side lengths of 2.6, so every single one of these has got 2.6 on each side. Verity makes these 2 shapes by placing tiles side by side, shape 1, shape 2, and it asks us to calculate the perimeter of each shape. Right, now remember the perimeter is where we add all the sides together. Okay, now the problem with this is that we need to make sure that when we figure out the perimeter, we are figuring out the perimeter of the shape that is made. Now what I mean by that is that that's the shape that's made there. That's the perimeter of the shape that's made. So what you should notice is there's a few lines on there like that one, 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 that are no longer part of the perimeter because they're now inside the shape and not part of the perimeter. That's the perimeter. So when we add them up, we're only adding up around the outside of the shape, not these lines that make up the inside. So 2.6, 2.6, 2.6, 2.6, 2.6, right the way around. Okay, or an easier way of doing that would have been, we'll just count how many of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then the quickest way to do it is to do 10 lots of 2.6, which is 26 centimeters. Okay, you could have added all that up properly, 2.6 add 2.6 add 2.6, but that's a quicker way of doing it. Okay, so let's do the same thing for shape 2. Highlight around the outside of it, and then count. Remember, we're getting rid of that, and that line. Count how many 2.6s we're going to need. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 this time. And that gives us 36.4 centimeters. Okay, so one thing you should notice there is that even though they're both made up with 6 tiles, the perimeters are different. Okay, right, part B. Maddie has 9 of the same square tiles. She arranges her 9 tiles to make a shape that has the smallest possible perimeter. Sketch Maddie's shape. Well, if we've got 9 tiles, if we think back to this one, what we want to do is effectively, we're going to be using the 9 tiles. We want to make sure as many of the lines on the squares of the tiles are inside the shape. Because when they're on the inside of the shape, they're not around the outside, making the perimeter bigger. So how can we arrange them so that most of the lines around the outside of the tiles are inside the shape? Well, the best way to do that, and the fact that it says 9, you should know that 9 is a special type of number. 9 is a square number, which means that we can arrange these in a 3 by 3 square like that, because what that does is it creates a shape where, look at how many lines are going to be not included in the perimeter. So there's your perimeter around the outside, and that will be the best way to make sure the perimeter is as small as possible. Okay. Part B2, calculate the area of Maddie's shape. Well, the area will be 9 of them, 9 of those tiles only. So we need to figure out the area of one tile. How do we figure out the area of a square? We times the length by the height or length by the width. So area of one tile is going to be 2.6 times 2.6. But another way of thinking of that is 2.6 squared, you're multiplying it by itself, and that's where the word square comes from, as opposed to a power 2. So 2.6 times 2.6 gives me 6.76. So each tile takes up a space of 2.76 centimetres squared, and I've got 9 tiles, so I'm going to times that by 9, and that gives me an answer of 60.84 centimetres squared. Okay. Right, so let's have a look at the mark scheme. Question 5. So for part A, down here, you get an M1 for either doing 10 times 2.6 or 14 times 2.6 or equivalent. The equivalent part there means that if you had added up, if they can see you adding up 10 2.6s, you would have got a mark there. So I'm going to get an M1 because they can see me doing multiplications, and then we're going to get 2 accuracy marks, one for the 26 and one for the 36.4. Right. Part B. B1 sketches a 3x3 square. So there's no real method marks available with that, and it sounds, I think that when I first read that question, it sounds a really tricky question. Actually, you're going to have to like do loads and loads of different arrangements and then count the perimeter up each time. But if you think about it and think about this idea of getting rid of some of the lines from the perimeter, then grouping them all together in a square makes the most sense, doesn't it? Okay. And part B2, okay, 9 times 2.6 squared or 3 times 2.6 squared. Basically what this is doing is have you found out the area of one tile and times it by 9? Oh yeah, we've done that, haven't we? 2.6 squared, which is there, times 9 to get this, okay? So we've got an M1 and then our A1 for getting 60.84.